Hi there, welcome to PyMath. In this video, let's try to solve the identities that are shown in the screen. Cos 60 minus A, cos A multiplied by cos 60 plus A equal to 1 by 4 cos 3A. And similarly, prove tan 60 minus A, tan 60 plus A equal to tan 3A. Before we get to solve this, I have created a similar video for sine 60 minus A sine A multiplied by sine 60 plus A equal to 1 by 4 sine 3A. You may have to look into that before you watch this video, just because this is a similar concept and it will help us to solve the tan identity that is shown here. So let's get to the problem first. Let's take up the first problem and let's call the tan identity as a second problem. Before we get to solve this, I want you to review or remember sum to product identities as shown below, and so as the other formulae regarding cos 2a and sine 3a and cos 3a. I hope you know all these identities and formulas before we get to solve this problem. So let's get to the problem. So for the first problem, which is cos 60 minus A cos A multiplied by cos 60 plus A, it looks like our identity, sum to product identity, which is shown here, which is 60 plus A and 60 minus A, looks somewhat similar to this identity. But to make it exactly the same way so that we can get to cos C plus cos D, you need a 2 to start with, and you need a C plus D by 2 format and C minus D by 2 format. So let's make it by having 2 multiply and divide this, the left hand side part of this identity, 2 multiplied by cos. Let's get that we need a 2 in the denominator to make it look like C plus D by 2, right? So let's multiply by 2, 60 minus A by 2. So you are multiplying and dividing by 2. So it doesn't change the value. Multiplied by, let's bring the cos 60 plus A ahead. So let's do cos again. 2 is being multiplied to the denominator and numerator. And then let's bring up this cos A. So we have transformed it a bit to make it look like the right hand side of this sum to product identity. So 1 by 2. So let's simplify it a little bit before we actually write the cos C plus cos D. So you're talking about 2 is getting distributed. So 120 minus 2a divided by 2 cos 120 plus 2a divided by 2 multiplied by cos A. So this looks exactly like cos C plus D by 2, cos C minus D by 2 multiplied by 2. So it's exactly the same format that we need to have cos C plus cos D format. So here, this is our C, this is our D. So let's write it as cos 120 plus cos 2a multiplied by cos A. So we got to this simplified format, but let's calculate what cos 120 is. Cos 120 is cos 90 plus 30, which is in second quadrant. Because it's a 90, we got to change the cos to sine. And since we're talking about second quadrant, cos is negative, you got to put a negative. We got to put a negative sine 30, which is minus 1 by 2. So we are talking about cos 120 as minus 1 by 2. Cos 2a in terms of cos is cos 2a equal to 2 cos square a minus 1. So let's write that. So plus 2 cos square a minus 1 multiplied by cos a. So minus 1 by 2 when added up will give you minus 3 by 2. So minus 3 by 2 plus 2 cos square a. So let's distribute this 2. So we will get 1 by 2 minus 3. Sorry, I'm missing this cos a carried over from here to here. So minus 3 plus 4 cos square a divided by 2 multiplied by cos a. Let's distribute the cos a. So we will get, let's multiply these two 2's. So we will get 1 by 4 cos cube a. So let's take up the 4 cos square a multiplied by cos a first, and then you will get minus 3 cos a. So which gives us same as our cos 3a formula. So it's 1 by 4 cos 3a, which is same as our right hand side. So this is how we proved it. So all you got to remember is this sum to product identities and cos 2a formula, and then just simplification of what is given in the left hand side will get you to 1 by 4 cos 3a. This is good to remember, and this will help you in solving some advanced problems in competitive examination or in your schoolwork. So let's remember this, and also as I mentioned, I always made another video for sine 60 minus a, sine 60 plus a as 1 by 4 sine 3a. So that is one thing, and now we have proven our first problem. Let's get to the tan problem, the tan identity that is given there, and let's see how we can do it. So let me get rid of this. Then let's get to solve the tan identity that is shown there. So before we get to the tan, so we know the sine 60 minus a sine a 60 plus a is 1 by 4 sine 3a. And similarly, we know cos 60 minus a cos 60 plus a is 1 by 4 cos 3a. So we can write tan 60 minus a tan a tan 60 plus a equal to tan 3a. This is what we are trying to prove. So this can be written as sine 60 plus a sine 60 minus a sine a divided by cos 60 plus a cos 60 minus a cos a. So this is how we can write it. But you also know this one is same as what is shown here, the one that we proved before. So it's 1 by 4 sine 3a, and for the cos 60 plus a cos 60 minus a part of it, we just proved that it is equal to 1 by 4 cos 3a. So this 1 by 4 in the numerator, 1 by 4 the denominator gets cancelled out. So you will get sin 3a by cos 3a is tan 3a. This is how you can easily prove it, provided you remember 1 by 4 sin 3a for the numerator part of it, which is for the sine, and the 1 by 4 cos 3a for the denominator part of the identity that is shown there. So these three actually are good to be remembered like any other useful identities, so that it will be useful again for solving some advanced problems. Thank you for watching. If you wish to subscribe to this channel, it will help us make more videos. Thank you.